So this is our project, and we have a couple details to take care of. The first thing is the tentative timeline. Tentative meaning, of course, it's subject to change.
After weeks of planning, teacher Scott McComb is launching the Wing project.
November 17th, we will design the wing. December 1st, we will build the wing.
Over a period of 6 months, students will learn principles of physics and engineering as they design, build, and test wing structures, eventually presenting their results to a panel of engineers.
It started off as basically a pretty simple design.
They will work in teams of 3, with each student selecting the role they wish to play.
So the project managers are going to go stand over there in just a moment. The design engineers are going to go stand over there, and the test engineers are going to come up here. I want to remind you, here's your chance to not work with your friend and not hurt their feelings. If you have a special someone, a little heartthrob in this classroom, don't work with them either. It's a disaster. All right? Questions or comments?
Once the students have decided on their roles, McComb asks them to spend a minute thinking about who they want on their team.
Think about your gifts. Think about your areas for improvement. Think about who you need to help. All right. Would you please go ahead and find a team of 3 people? You guys gonna be a team?
Yeah.
Outstanding. Fill that out for me. Ladies, you gonna be a team?
Yeah, don't worry. We can
All right, fair enough.
To avoid conflict down the road, the teams must first complete a form that details how they will work together.
How will we share our work and track our progress as a team?
Maybe like a check-off sheet or something like that.
McComb looks over and approves each agreement.
Let's say we're working together, and let's say the problem is I break my word and I'm really lazy. We know what the problem is. What do we do about it?
Talk to you.
Okay. Will you just write that down?
As the project progresses, teams develop designs, determine construction techniques, and test the strength of their wing structures.
Okay, we can go until the actuators fall off.
Light one, Scotty, light one.
There is no...
Each round of testing teaches them something new.
19.5 centimeters.
I remember after the first round of testing, we said, well, it looks like we need to improve on quality control, which is a play way of saying these are pure crap. And so we cut back the number of wings to be tested per group every round. We made a long list of variables we were going to control. We made a long list of data we need to make sure we collect. We figured out the importance of including a screen in the background so we could measure deflection more accurately. We learned the importance of going from videotape to still shots so we could quickly analyze the data, and so forth. So the second round was a much smoother test, and the third round even more so.
Great.
During the final testing round, the class is joined by local aeronautical engineers who assist in the analysis of test results.
Kind of looks like you failed this main section right here.
And will serve as judges for the students' final presentations. Subject matter expert Doug Gross enlisted the volunteers.
I couldn't do this project by myself, so what I did to get some backup is I emailed my colleagues and I asked them to come and participate for a few hours on 2 different sessions, one for the testing and one for the evaluation of the students' projects. And by the time the dust settled, I had about 20 volunteers, which is pretty amazing.
Students are encouraged to reflect on the project in a survey McComb has asked them to complete.
You remember the survey that you filled out? I had a chance to tabulate those results, and here's briefly what they have shown. What was the most challenging part? Getting data, getting team to cooperate, not being shown at all how to build or given information how. And that leads to an interesting question. How many people in here agree with that sentiment? Max, what about you?
I mean, as you noticed, almost every single group until the last design did totally different things.
Yeah.
And I thought that was really cool because that we got to see so many different designs. Instead of, if you had told us, we probably would have, half the class would have done something that you suggested, and the other half of the class would probably have done something that you sort of suggested.
All right.
I was going to say that it's a lot better to learn something on your own than it is to have a teacher tell you it. Because if a teacher tells you it, you might remember it 2 weeks later, but if you learn it yourself, you're going to remember it for pretty much the rest of your life.
How you learned it.
As I look back on the project, I wish that there were a more formal write-up with more formal engineering terms, a better demonstration of engineering knowledge. In terms of teamwork, in terms of data collection, in terms of excitement about learning, gosh, they exceeded all expectations.
Slow, 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 slow.
To have a student say, I want to do another, is a rare and wonderful thing.
Oh,